friction factor, grades 4 through 6. Okay, in your folder, you will have the background information. So some of the key concepts that you're going to be going over today is what friction is, a force that slows down moving things. You can go ahead and continue to talk about kinetic and static and the difference, and you can go ahead and read the background information on that. There is going to be a laminated vocab for you to keep at your station or hang up in your classroom. It's up to you. Some of the materials that you're going to be needing in this tub is the friction apparatus, which is this block, this set. It's going to have 3 different types of surfaces. It's going to have a polished wood surface. It's going to have a foil or a shiny surface. And then the last surface is going to be sandpaper. You're also going to have additional surfaces that we are going to tape on a little later. It's going to be the bubble wrap and also the wax paper. You're going to have rulers, you're going to have marbles, and you're also going to have some of these little sticker dots to place down where your marble stops, and then you can go ahead and measure from there. When you're doing this activity, you need to find a spot for your students on the ground where there's carpet. I don't have any carpet available in my house, so what we're going to do is we're going to improvise, and I'm going to use a bath mat. So pretend that we are in the corner of your classroom somewhere, and I'm going to set up my friction block, wood, foil, and my sandpaper. This is the activity and the journal page. It's a combo page this time around. And the very first thing you're going to do is your student is going to have a hypothesis. It's going to be a prediction, a guess. I think that what will have the least amount of friction. Okay, so which surface is going to have the least amount of friction? That means the easiest slide. That means when a marble goes down here, it's going to go the least amount distance. So it's going to go like a short distance instead of a long distance. So some kids might have problems, just distinguishing between the two. So they make a hypothesis, and then they're going to go ahead and follow the data table. The very first row, or the very first column, I'm sorry, is prediction of distance. Okay? We're always going to start at the same spot. So just make sure that if they're going to start right here and drop their marble, they're going to start here each time. Okay? They're not going to start over here. They're going to start over on those sides. Okay? So they're going to go ahead and make their prediction. The polished wood. How far do you think this marble is going to slide down? So let's just say I think it's going to land right here. So my distance from here to there is about 9 inches. So what I'm going to do is I'm going to write down my prediction. I think it's going to be 9 inches. Foil is a little slippery, so I think it's going to go a little further. So I'm going to say 12 inches. I'm going to write down 12 inches. Sandpaper, pretty rough. I think it'll go about 5 inches. And so forth with the bubble wrap and the wax paper. These are all predictions. Okay, the next few columns are trials. We're going to do each of these surface areas 3 times, and then we're going to add all those distances together. So I'm going to show you one. I'm going to start with the polished wood. I'm going to start right here, and it's going to go ahead and stop there. And then these are little sticky tabs. You can go ahead and remove your marble if you choose to, and then you can measure. So this is about 6 inches. So I'm going to write down 6 inches for my trial 1. Okay, let's say it falls again. Okay, and right around here. My second distance is about 6.5. Okay, my third distance is about 7. Okay, so what you're going to do is you're going to have 6, 6.5, and 7. You're going to add all that together to have a total distance for 3 trials. You're going to do the same thing for the foil. You're going to do this 3 times. Find a total. Sandpaper, find a total. Okay? And then you're going to go ahead and take your bubble wrap. Take one of these blocks, and what you're gonna do is you're gonna take your tape, and all you're gonna do is just kind of tape around it. Here we go. Just like that. And you're gonna do with the bubble wrap. So what you're gonna do is you're gonna start over here, oops, slide it down. Okay, and if it only goes that distance, 2, you're gonna go ahead and write down 2 for the bubble wrap. And you're gonna do that 3 times and then find a total distance. Then you're gonna take the wax paper. Okay, take another one. You're gonna tape it down and do the same exact thing. So your conclusion, looking at your data table, okay, which surface type had the least amount of friction? You're gonna write that down. And then you're gonna answer 6 questions. Was your hypothesis correct or incorrect? Number 1, which surface had the least kinetic friction or easiest slide? Okay, and then so forth. You're going to answer number 2. Number 3, I think number 4, I'm gonna go through the last 3. What happens if I double the weight of the marble? Well, if I double weight the marble, the friction force is going to increase. What happens if I keep the weight the same, but double the surface area? So what if I had this sandpaper be a lot grittier or even more rough than it already is? So what happens to the frictional force is that it's going to increase as well. Let's see. The frictional force is affected by the weight and also the surface area. So those are the questions that they're going to conclude with, and that's it.